Hi students. So today in this video we are going to see about the p block elements and its properties. Okay. So it's a very important chapter in any competitive exams, even on the board. Actually this very important chapter. So now let us straight away go to the videos and see like what are the properties of p block elements. So first, where the p block elements is. If you take the entire periodic table, like the one particular end you have like S block elements, in middle you have D block elements and F block elements, and then towards the left of mine, okay, the left side, so you have a p block elements which has the range between group 13 to group 18. Okay, so group 13 to 18 we have elements in the p block. Okay, so like whether all are non-metals here. So generally p block elements have non-metals, but do they have metals? Yeah, so definitely they do have metals also. For example, aluminum, you have platinum, right? So aluminium, then you have bismuth. So all these are metals. Okay, so p block elements contains metals, contains non-metals, contains metalloids. They do also contain metalloids. Okay, so now let us see the general properties of p block elements. Okay, so first, general electronic configuration. General electronic configuration. So general electronic configuration is NS2 NP1 to 6. Okay, NS2 NP1 to 6. If you take group 13, it has NS2 NP1, group 14 NS2 NP2, group 15 NS2 NP3, group 16 NS2 NP4, and group 17 NS2 NP5, and group 18 NS2 NP6. So that is why noble gases placed at the last, because they have completely filled electrons in S and P. Is that okay? So now let us see one by one the properties. Is that okay? So what happens to the atomic size? So first let us see the atomic size. So when we go along the period, the electrons are added to the same shell. If you go along the period, the number of shells remains same, but the electrons get added. So when the electrons is getting added, number of protons also will get added simultaneously. So when you go along the period, since electrons are added to the same shell, so what happens? The nuclear charge will increase. So what is nuclear charge? The attraction between the protons and the electrons. So since the attraction between the protons and the electrons increases, the size will keep on decreasing. So going along the period, the atomic size decreases. Now what happens when you go down the group? The electrons added to the new shells, right? So for example, if you take say boron and aluminium, boron contains say two shells, like K and L. And when you go to the aluminium, K, L and M. So every element you go down, the new shells will be added. So the electrons are added to the new shells. So what happens to the nuclear charge? It will decrease. As the distance increases, the nuclear charge will decrease. So as the nuclear charge decreases, the size will increase. Okay. So going along the period, what happens? Along the period, atomic size decreases due to increase in nuclear charge. Going down the group, what happens? Atomic size will increase as the nuclear charge decreases. So everything is related to the nuclear charge. Okay. Now what happens to the ionization energy? Ionization energy. What happens to the ionization energy? So when you go along the period, the electrons are added to the same shell, the nuclear charge will increase. So the amount of energy required to remove an electron from outermost shell or valence shell is called ionization energy. So when you go along the period, since the nuclear charge increases, it is very difficult to remove. So going along the period, what happens to the ionization energy will increase. Ionization energy will increase everything. So I can tell that ionization energy is directly proportional to nuclear charge, inversely proportional to size. Okay, if the size is big, the ionization energy will be low. Okay, so going down the group, what happens? Ionization energy will decrease. Same reasons. When you go down the group, the nuclear charge decreases, so ionization energy also decrease. So what is the special characteristics of ionization energy? Those elements having exactly off-filled configuration. Those elements having exact off-filled configuration will have more ionization energy. Those elements having fully filled configuration also will have more ionization energy. Okay, so 2 points. What is it? Exactly off-filled, and fully filled. Are more stable. So ionization energy will be high. Okay, understood? Exactly off-filled and fully filled are more stable, so the ionization energy will be more. So for example, nitrogen, oxygen, if you compare, nitrogen will have more ionization energy. Why? Because nitrogen has atomic number 7. So 1s2, 2s2, 2p3. So p orbital 3 exactly off-filled configuration. Therefore it is more stable. So oxygen will have p4. So 1, 2, 3, 4. It will be paired. So when you compare oxygen and nitrogen, along the period oxygen should be more, but nitrogen is more because of the stable configuration. And when you compare say fluorine and neon, obviously neon will have more because completely filled p orbital. So therefore they have very high ionization energy. Is that okay? Now you have clear idea about what is ionization energy. So going along the period, ionization energy will increase. Going down the group, it decreases. Everything related to nuclear charge. So more nuclear charge, more ionization energy. Less nuclear charge, so less ionization energy. Is that fine? Understood? So successive ionization energies are greater. So what do you mean by successive ionization energies? If you remove one electron, it is called first ionization energy. Suppose if you remove another electron, it is called second ionization energy. So ionization energies will always be more for successive, you remove the electrons. Is that fine? So hope you understood. So now let us go to electron gain enthalpy. So what will happen to electron gain enthalpy? Electron gain enthalpy, the another name is electron affinity. Electron gain enthalpy. So what do you mean by electron gain enthalpy? The amount of energy released when anion is formed neutral gaseous atom and it is exothermic. So for example, general representation Clg plus E so it will release energy. Okay, Cl plus E gives Cl minus plus energy. Is that okay? So this is the definition for electron gain enthalpy or electron affinity, the amount of energy released when anion is formed from neutral gaseous atom. So now what happens to the electron gain enthalpy when you go along the period? What happens to the electron gain enthalpy? Going along the period, the electron gain enthalpy will increase. Again the same reason, the electron affinity or electronegativity, electron gain enthalpy is directly proportional to nuclear charge. Okay, so going along the period increase and going down the group it will decrease. So we think that, so which element will have the highest electron gain enthalpy value? What do you think? Is the fluorine is your answer? But it's wrong. Okay, so everyone thinks that yeah, it's a highly electronegative element, so it's supposed to accept electron easily and it reaches the neon. Yes, absolutely. But chlorine has the most electron gain enthalpy and not the fluorine. The reason, okay, so if you take fluorine 2, 7, right, K shell contains 2 electrons, L shell contains 7, right, K, L. Right. Now chlorine 2, 8, 7. K, L, M. 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here 7, 1, 2, 3, 4, 5, 6, 7. Now you compare. L capacity is 8, right? L shell, what is the capacity? 8 electrons. But here how many electrons are there? 7. 7 electrons are there. But if you take chlorine, it's supposed to be M shell contains 18, but how many is there? 7 is there. So when you compare fluorine and chlorine, chlorine has the bigger shell, right? So the electrons are very easily accepted, correct? So what is electron gain enthalpy definition? When you add an electron, it will accept electron and it will become an anion and it releases more energy. Am I right? So if you compare fluorine and chlorine, the fluorine supposed to be the most, but it is least. Less. I don't say least, but it is less when compared to chlorine. The reason, since fluorine, that is fluorine has K and L, and L shell maximum capacity is 8, but already 7 electrons are there. So any electron is added there, rather than attracting, it will repel because more electrons are there and concentrated in one particular small shell. So when any electron approaches, rather than attracting, it will repel. So we can say electron-electron repulsion. So because of that repulsion, it won't accept much, so less energy is released. Whereas in chlorine, compared to fluorine, it is bigger, right? So it readily accepts electrons and release more energy. So electron gain enthalpy for chlorine is more than that of fluorine. So what will be the electron affinity is Cl2, F2, Br2, I2. This is the order. Okay. So electron affinity order will be chlorine, fluorine, bromine, iodine. I hope you understood like why it is not fluorine but it is chlorine. Yes. So you know that exactly off-filled configuration and fully filled configuration is more stable. So why would those elements having the stable configuration should accept electron? Just think and see. It can't, no? So therefore it will have 0 electron gain enthalpy value. Those elements having stable electronic configuration will have 0 electron gain enthalpy value, that is electron affinity. Okay, it will have 0. And especially if you take noble gases, rather than being even 0, it will be positive. You know the electron gain enthalpy is negative. Am I right? But here what happens is, since it is completely filled, they don't even try to accept. But you can make them to accept by supplying energy to it. So here electron gain enthalpy for noble gases, electron gain enthalpy for noble gases is positive, which is nothing but what? Endothermic. Supposed to be exothermic, but here it becomes endothermic. So you are supplying energy to the noble gas and making them to accept. So therefore it is positive. Delta H is positive. So therefore it is endothermic. Understood? So I am taking the p block elements, and generally I am just explaining you what will happen for each properties. Okay. So in that case, like next we are going to see is electronegativity. Okay. So what is electronegativity? Electronegativity. So what do you mean by electronegativity? Tendency of an atom to attract shared pair of electrons towards itself. Tendency of an atom to attract shared pair of electrons towards itself is nothing but electronegativity. So what happens when you go along the period? The electrons are added to the same shell. When the electrons are added to the same shell, what happens to the nuclear charge? Nuclear charge will increase, and tendency to attract electrons will also increase. So the most electronegative element in the periodic table is fluorine. Okay. Next is supposed to be chlorine, no? But it is oxygen, then nitrogen, then chlorine. Right? So fluorine, oxygen, nitrogen. That is the reason why fluorine, oxygen and nitrogen get involved in the hydrogen bonding, but not chlorine, right? Chlorine, they don't form hydrogen bonding. Is that okay? Understood how it is, right? So when you go along the period, the electrons are added to the same shell, the nuclear charge increases, right? So these are the properties which we studied, like what happens when you go along the period, right? Understood, students? Thank you, students.